So in this video, we'll do some more problems on expected values and more applications, real world applications of expected values. So in problem 4, we have another gambling game, a spinner, and the outcomes are 1, 2, 3, or 4. And for each outcome, we have a probability of the outcome, which is 1/8 for 1, 1/8 for 2, 1/2 for 3, and 1/4 for 4. Just make sure they all add up to 1. The question says, what is the expected value for the number on which the pointer lands? It is somewhat similar to making number of points. So let's just assume this. If it lands on 1, you make 1 point. If it lands on 2, you make 2 points. Lands on 3, you make 3 points. And lands on 4, you make 4 points. So we have the payoff and the corresponding probability of the payoff. We multiply the number in the first column with the corresponding number in the second column, and we get payoff times the probability of payoff in the last column. We do that for every row. So we get 1/8 plus 2/8 plus 3/2 plus 1 is 2.875. So the expected value for the number on which the pointer falls is about 3. It's 2.875. So roughly that is the average over a period of time and over many trials, that the average number on which the pointer would land. Now the next question, we have a simple application of expected values. So you'll see how expected values are used in the real world. So we're talking about an insurance company that sells insurance. When we buy insurance, we pay a certain amount of money, and that amount of money is called the premium for the insurance. So here is a basic example of how a premium would be calculated. So we've got an insurance company that has some collected data from which they get these numbers. So it's about a certain insurance, an average of 70 in 100 will never file a claim. So not filing a claim would mean that the insurance company pays nothing, and that happens 70% of the time. 20% of the time, the insurance company might have to pay $20,000, about 20% of the time. 6% of the time, the insurance company might have to pay $40,000. 2 out of 100 is the probability that the insurance company will pay $60,000 in a claim. 1 out of 100 chance that it will pay $80,000 in a claim, and 1 out of 100 chance that it will pay $100,000 in a claim. So payoff times the probability of the payoff. So the first column times the second column is equal to 0. So we do exactly the same type of calculations. Payoff times the probability of payoff for each one of the rows or each one of the possibilities. Just make sure that the numbers in the first column add up to 1. Add up all the numbers in the last column, and that gives us the expected value of that particular amount that they have to pay per insurance claim. So what exactly does expected value mean in this particular context? So if an insurance company sells many policies, a large number of policies, that then the amount of money they can expect to spend on each policy sold would be about $9,400 in claims. So that is per policy sold. So $9,400 per one policy sold. This is what their calculations show. So if they're going to figure out what premium to charge a customer, then they're going to have to mark uh, their amount above $9,400 because this is the amount that they can expect to pay for each policy sold. On an average, it doesn't mean that every policy they'd have to pay a certain amount of money because, as you can see, 70% of the times they get away without paying anything in claims. So let's look at the next page to answer questions related to this. So the question says calculate the expected value and describe what this means in practical terms. So we've looked at this in the previous page. The expected amount that the insurance company will pay per policy sold is $9,400. What this means is that if many insurance policies are sold, that is when, on an average, the company can expect to pay about $9,400 per policy sold. The next question is how much should the company charge as an average premium so that it breaks even on its claim costs? So if the expected um, amount that they're going to pay in the form of claims is $9,400, to break even, the company will charge exactly or about $9,400. If they want to make a profit, then they go and charge over $9,400. So the third one is how much should the company charge to make a profit of $50 per policy? To break even, we just figured out that what we need to charge is $9,400, but if we want to make a profit of $50 per policy, so it would be $9,400 plus $50, which is equal to $9,450. Here's a real world example of where expected values are used. An oil company is thinking of drilling in two sites. Um, they probably don't want to drill in a site that is not going to give them returns. So they want to figure out which site is going to give them better returns on their investment because drilling costs money. So look at site A and look at the details given. For site A, the profit if oil is found is 80 million and the loss if no oil is found is 10 million. So a loss is negative, a profit is positive. The probability of finding oil is about 0.2. So we need to figure out the expected profit in this case. So in each case, we're going to figure out the expected profit for the company. So there are only two possibilities. Either oil is found or oil is not found. We know what the probabilities are for the oil to find oil. And 1 minus that, so 1 minus 0.2, which is equal to 0.8, is the probability that the oil will not be found. For each case, there is a payoff in terms of profit. If oil is found, the payoff is $80 million. If oil is not found, the payoff is a loss, which means a negative $10 million. Now we find the expected value by multiplying the number in the first column, which is the payoff, with the probability of the payoff in each row. And in the first case, we get $16 million. In the second case, we get negative $8 million. When we add these two numbers, we get 8 million. That is the expected value of the profit or the expected profit if drilling is carried on in site A. Now let's look at site B. Now for site B, the details are given. Profit is pretty huge. The profit is 120 million if oil is found. And the loss is also pretty big if oil is not found. It's $18 million. So a profit is positive, a loss is negative. the probability of finding oil is zero point 0.1. So if you're lucky and strike oil, then um, the profit will be pretty huge. But let's see if we can figure out what the expected value of the profit is in this case. It almost seems tempting because you're going to make more money if oil is found, but let's see what the numbers tell us. So for site B again, there are only two possibilities. Oil is either found or it's not found. If the oil is found, the payoff is 120 million in profit, so it's positive. If the oil is not found, we have a loss of $18 million, so that is negative. What is the probability of the payoff? The probability of the payoff is zero point 0.1. Probability of the payoff in this case for a loss, it is 0.9. The probability of loss is pretty high. How do we figure out the last column? We multiply the first column with the second column to give us the last column, which is payoff times the probability of the payoff. When we do the calculations, we come up with a negative number. So the expected value here is a loss of $4.2 million. So that is the expected profit, negative 4.2 million. So clearly, even though the profits look very attractive in the second site, if oil is found, we need to still go with the first site because that is a safer bet.